Hello everyone, welcome to another video. So the problem of the day is remove k digits, and the problem statement is given a non-negative integer s represents a string, remove k digits from the number so that the number is smallest possible. There is a note given. The given num does not contain any leading zeros. So in this question we have to consider three conditions. At first we have to remove k digits only. The second condition is the new number which is generated should be the smallest possible, and the third condition is our result should not contain any leading zeros. So let's quickly see the given examples and decide how to approach this problem. So according to the example, we can at most remove three characters from our given string. So let's take a result array where we will store our final result, and we will start our iteration from the first index of our given string. So in our case, at first we got 1, and we will check some conditions that if the result length is 0, then we will simply add the character to the result string. The second condition is if the character is smaller than its previous character. We will see that condition in our next iterations. So in the first iteration, we can see the result length is 0, so we will simply add 1 to it based on our first condition. Then we will iterate further. Our second character is 4, and according to the condition, if the present character is greater than the previous character, we can add it, and if it is not, then we have to perform some operations. We will see that later. Now let's iterate further. In the next iteration we will get 9, so 9 is also greater than 4. We will simply add 9 to our result. In the next iteration we can see we got 8. Now the present character is less than the previous character. 8 is less than 9. In this case, what we have to do, we will iterate back in our result string till we got a character or a digit which is less than or equals to our current character, that is 8. So in this example, if we traverse back in our result string, here we found 4. So 4 is less than or equals to 8, thus we can add 8 in this index. So for that we have to remove our 9 from our result string. Thus, the updated result string will be 1, 4, and we have removed 9 from our result string. Instead of that, we will add 8. And as we have removed 9, we will decrease our value of k, because at most we can remove 3 characters or 3 digits from our result. So we have used 1. So we are left with 2 more characters which we can remove. After adding 8, we will iterate further in our main string. So we found 1. Again we can see 8 is greater than 1. So what we will do, we will iterate back in our result string till we found a character or a digit which is less than or equals to our present character, that is 1. So in our result string, if we traverse back, we find 4 which is not less or equals to 1. If we traverse back again, we found a character which is less than or equals to 1. So we can add our present character at this position. So for that we have to remove 2 digits, that is 8 and 4, and we were also left with 2 chances only. So we can remove these 2 characters and add our 1 in the place of 4. So our updated result value will be 1 and 1. And in the last iteration we again found a 1. So 1 is less than or equals to this its previous character, that is also 1. So we can add that character or our last character easily in our result string. Thus the final value will be 111. Hence we have to return this. Let's take the second example also to get more clarity. In the second example, to compute the result, we will again create a variable res, string variable res. At first we will check our length of the result, which is 0. So we will simply add the first character of our string, that is 1. Then we will iterate further. The character is 0, which is less than the previous character. So we have to replace it, right? So our updated result will be 0, and we will delete this. So now our k will be 2. In the further iteration, we found again a 0. 0 is equals to 0. So our updated result will be 0, 0. Next iteration, we found 2. 2 is greater than 0. We will simply add it. There is no need to remove any character. Next iteration, we found 9. 9 is also greater than 2. We will simply add it. Same with the next iteration. Because 9 is equals to 9, we will simply add 9. In the last iteration, we found 1. and 1 is less than 9. So we have to traverse back in our result string, delete k number of characters and add this character in a suitable position. So all total we can delete 2 characters. So if we delete last 2 characters of our result string, so k will be equals to 0 and the result will be 002, and we will simply add our 1 over here. Thus we have 0021 as our final result by now. But according to the note given in our question, the answer result must not have leading zeros. So we have to remove these two leading zeros, and thus our final answer will be 21, and we will return this. So let's see how we will code this problem. So at first, let's store the length of a given string, that is s dot length. Then we can check if the value of k given, that is number of deletion we can perform, is equals to the length or not. If it is true, that means the string contains k number of characters, and we, according to the condition of the question, we have to remove all of them. So in that case we will simply return 0, because if we remove all the k characters from a string length of k, we will be left with 0 characters, thus we will return 0. Now let's create a string builder to store our result. Let's name it as result, and then we can start our iteration in our given string. So we will start our iteration from 0th index, and we will iterate till we are exhausted with number of characters in our given string. Within this loop, we will create another loop which will traverse back in our result string if the current string is lesser than the previous string, and delete the previous strings also. So for that we need to create another loop, and here we will check if the previous value in the result variable. So result dot caret. So whatever our result is, we have to find the last character and compare it with the present character. So for that, result dot caret result dot length minus 1. This will give the last character of our result string. And if this is greater than the current character of our original string, that is s dot caret I. In this case, we were traversing back and deleting the last characters from our result variable. So simply we will use a inbuilt function result dot delete caret, and what we will delete the last character of our result. So that will be result dot length minus 1. So once we have deleted a character from our result string, then we have to decrease our k value. And this loop will iterate till k is greater than 0. That is, we can delete k number of characters from our result string, and also the result length must be greater than 0. This is the first condition we have discussed. When the result length is equals to 0, we were simply adding the first character from our original string. So that's why we have added this condition also. And what if all these condition doesn't satisfy? We will simply append the character in our result. So result.append s.caret I. And after appending each character in our result string, we will increase our pointer, so I++. So now we are done with our main logic, but we have to consider some cases, like if the length of the string is exhausted, but we haven't yet removed k number of characters from our given string. So in that case, we have to remove all the last k characters from our computed result string. So let's quickly write the code for that. So while k is greater than 0, so the loop will continue till k is not equals to 0, and we will simply delete the last k characters from our result string. As we need to delete the last characters of our result string, so we will go to the last index while result dot length minus 1. After deleting each character, we will decrease our k value. After this, we have to tackle one more condition where we have to remove all the leading zeros from our result string. So for that, we can take a pointer which will point to the first non-leading character in our string, in our result string. So let us initiate it as 0. Then again we have to run a loop. It will run till the length of our result string So it might be that there is no leading zeros in our result string. In that case, it will run till the length of the result string, or else while iterating we found a zero. So result dot char ptr equals to 0. So our pointer is starting from 0th index. At beginning it found a character 0. Then we will simply increase our pointer to the next index, and it will again check if the next index has also the same value, that is 0. So like this it will keep on iterating till it found a character which is not equals to 0, that is a non-zero character. And then after coming out of the loop we can simply use a function result dot delete. So this function can take two parameters. One is the starting index from where it will start deleting, and second is the ending index till where it will delete. So we have to delete leading zeros from 0th index till the calculated pointer value. That means how many leading zeros we have in our result string is calculated using this variable. So this is our starting index, this is our ending index, and we will delete all the characters present between these. Thus we can remove all the leading zeros in our result string, and at last we have to return our result. But here we have to check another condition, that after removing all the characters from our result string, are we left with some characters in our result string or not. So let's check it. If the result dot length is equals to 0, so we are using a ternary operator here. If it is equals to 0, then we can simply return 0, else that means we are left with some characters, so we have to return that. But our result is string builder and we have to return a string type, and thus we need to call toString method. So result dot toString, and that's it. This is all about the code. Let us quickly compile and run. So there are some typing mistakes. This will be caret and the K will be capital. So let's fix that quickly. So we have fixed all the issues. Let's compile and run again. Our code is compiling fine. Let's submit our code. So our code has successfully passed all the possible test cases. Now let's talk about the space and time complexity as well. The expected space and time complexity was big O of OS. That was the length of our given string, and our code is iterating through each character of a given string S. Thus, the time complexity is big O of S. So we will not consider the inner loop, because at most, at the worst case, it will iterate k times. Thus, we can ignore that, and our final time complexity meets our expected time complexity. And also, to store the result we used a string. Thus the space complexity is also big O of S, because at most it can store the whole original string. Thus the space complexity also meets its expectation. I hope you liked this video, and if you have learned anything new from this video, please like, share and subscribe, and let's meet in another video. Till then, happy coding.